everybody. It is Mike Levin on Friday, January 14th, 2022. So I got the day and the year all correct this time. So hopefully I don't restart this video. I'll keep my momentum going. Oh, what to talk about, what not to talk about. Boy, so many parts in motion. Even that is a point in and of itself. The more moving parts you have and the more parts that are in motion, the more likely for things to go wrong. So that is when you are on most keen alert. Like right now, I am on my drive to pick up my kid for a potentially 3-day weekend, because I have Monday off from work. That would be awesome to have them for 3 days. And it's dependent on whether they have their Klondike Derby meeting on Monday or not, which again is awesome. So if it ends up to be a 2-day weekend with them, the third day is to do the planning for an activity that I cherished growing up. I wasn't a great Boy Scouts or Scouts person. I stopped after I think not even getting one badge, because they said to me, you got to start pursuing merit badges or stop. So I stopped being on the rigorous, this is a testing thing. Now I could have gained some good skills. Looking back, it's like, oh, why wasn't I on the merit badge brigade? The reason is because I really just did it for the social outlet. I liked going there, hanging with my friends. Scott Seville, if you're still out there, hey, shout out. Anyhow, Klondike Derby was one of my more treasured memories from Scouts, going out there in the cold, pulling that sled along the trail to different goals. And, it really hardened me as a person, able to just, suck up and take it, as far as that really cold weather and having to just forge on. Probably the closest, we softies get to things like the real Klondike Derby in real life. Especially as a kid, sure. Extreme sports people have those experiences all the time in adulthood. But as kids growing up, to really push ourselves further than staying out in the cold during a snowball fight or whatever, or building an igloo, these scouting adventures were kind of it for me. And I am super glad they are a thing for my child. So, those parts are in motion, the transportation and planning of a weekend like that, but then also on the professional front as well. I have moved to Jupyter Lab desktop version. So it's an Electron app, just like VS Code and Slack and a number of other popular things out there. It's a web-based graphical user interface for desktop apps, and it offers a great way for developer familiarity, people who know how to program for the web, particularly Node.js stacks, JavaScript stacks, can step very comfortably into creating standalone apps that run on your desktop, just like any other program you would run, like the Microsoft software suite, Word or Excel. But it's all written with the components that are used to make the Chrome web browser. So Chrome was open sourced, it's called Chromium, and then the parts that build Chromium have been extracted into a development platform called Electron, and some very big apps have recently been ported to Electron, ported or written, or they've become popular. Certain Electron apps have become popular, VS Code from Microsoft being the top among them, and Jupyter, the company Jupyter, which you used to only be able to get their software easily installed through an Anaconda install, some 500 megabyte download and all this stuff you might rarely use, to a much smaller download and install now, which is available directly from Jupyter Lab. So they have two versions, kind of a classic version 4 notebooks, the first version being called Jupyter Notebook, or Jupyter Notebooks, Jupyter Notebook, I always forget, singular, plural, but through, new user interface design and philosophies going into the product, they have recently come out with a upgraded version, a new version, a different user interface to the same notebooks, and they call it Jupyter Lab. And Jupyter Lab is an Electron app, and it's fairly new. So this is the settling in time. This is the bleeding edge time for Jupyter Lab. And I try to avoid being on the bleeding edge in general, because things are going to settle down and become a lot easier to use, and all the frustration generating, time wasting gotchas that are there early on are generally shaken out and polished off, and you get a really good polished app. And Jupyter Lab itself in the web browser reached that point. Now that it's broken off as a standalone app, it's going through that settling in process again. There are issues regarding virtual environments and configuration commonalities, and user versus global path issues, recycling or making global the version of Python that Jupyter is using. And so this list goes onto these things that you can see changing on version to version, and each time you do a version upgrade, you got to uninstall a server component, uninstall the Electron app component, and then reinstall from a new .msi, or drag your exe in place. I think they distribute it both ways, which is another very interesting movement in free and open source software. It used to be extremely Windows unfriendly, because, the way you get free and open software on your machine is typically, if you're on a big popular distro that has really good repos, you do apt-get install, apt-get install, or it's just been abbreviated these days, I've noticed, to app install app name. And that on any Debian derivative Linux, which includes Ubuntu, the vastly popular Ubuntu, which is what you generally get when you install Linux on Windows through the Windows Subsystem for Linux. So it's really easy to install software on Linux machines. If it's not a Debian derivative, then you're using RPM, the Red Hat Package Manager, or which is more commonly called, I guess these days, the Remote Package Manager, in order to be a little more vendor independent or distro version independent in naming conventions. But it was Red Hat's, I believe, repository innovation in order to compete with Debian, which by that time was the leader in dependency chain resolution, because one of the biggest headaches of installing Linux software in the past has been incompatible versions of stuff, replacing each other on your machine, breaking previously installed apps. Common libraries were always a problem. So versions like Debian came along and said, oh, we'll just work that all out for you. And it worked so brilliantly that RPM, that most people know more through, I think, like the Yum program, the Yum interface on like CentOS type versions, anything Red Hat derivative for sure, which is the other main enterprisey distro branch of Linux, one being Debian, the other being Red Hat. That's the big split. And what got me onto this is that it's easy to install software on Linux, not so much on Windows, where historically it has not been. And there's two types of installs. Even to today, there's these dramatically different worlds. One is the inserting of external software through dragging a .exe, an executable file in place. It's been compiled for your hardware architecture. So dependencies aside, there's no reason EXEs can't just be dragged around on your machine and double-clicked and run from wherever they're at. And then the other way is to deal with all those strange issues that might need to be dealt with. Registry entries and putting libraries in place, things into your System32 directory is very common for this type of install. And then the software to be registered in the registry. So Windows has the worst of all worlds, you know. It has a registry, it has the ability for things to be dragged and moved in place, and it has properties in the file itself. So the installation story on Windows is a convoluted one. But the safety net is using an MSI, a Microsoft installer. So when you grab Jupyter Lab off of their site, you grab the .msi version for whatever your system is, generally 64-bit architecture. Now that Mac has ARM 64-bit with its own compiled optimized binaries, because somehow it's being handled on the Windows side. We're not seeing Windows 64-bit ARM distros yet. But it used to be, it was just 32 or 64-bit for Windows or Mac, and that was kind of your split. And the advice most often being, get the 64-bit for whatever platform you're on, Windows in most people's case in the world. I mean, honestly, there's a lot more people on Windows machines than there are on Macs, because the same reason Android is so popular in the face of iPhone. There's just so many reasons to not spend the more money and to get locked into the Apple ecosystem, thus Android. For the same reason, a lot of people aren't going to want to be on the Mac for their primary computer because Apple ecosystem. And even though the argument used to exist in the past, well, the Mac is a more legitimate platform for developers because Unix is more real of an operating system, you know, free and open source-ish, portable, the whole rest of it, than super proprietary Windows, you know, for many reasons, development reasons, you know, bug, you know, public inspection of code reasons, security reasons. And so for many years, developers just automatically preferred Macs because Unix. However, the Mac has never really settled on a good free and open source software repository officially from Apple. They've left that to the community. And the community came up with its premium offering, something called Homebrew. And you would brew install instead of apt install. So it's just the same thing, but a different nomenclature and unofficial, not officially supported by Apple. However, required for so many things that are mainstream on Apple. It became key to, say, Ruby on Rails, which was a web development fad for a while, which is now sort of fading out of, you know, popularity in favor of something which is equally faddish, these JavaScript front ends, where people are running from one to the next, retraining themselves every, you know, year or two, if they're lucky, on the next framework du jour, JavaScript framework du jour. So where is I going with all of that? You know, what brought me to that is choosing tools. It was certainly a choosing tools discussion. I started this whole thing by where I'm at today in these days, and it led to the installing Jupyter Lab as standalone version. Yeah, working out those kinks in the new standalone Jupyter Lab. So, NBDev, it's a new religion. It's a new way of viewing the world with a notebook-centric view. So, one would ask, why use notebooks at all, especially if you're going out of your way to use them for software development, creating pip installable packages and such, when VS Code is there from Microsoft ready to do the same thing. It has the same REPL engine, it has the same IPython interactive console for executing Python built right into it, running much like they do in Jupyter Notebooks under Jupyter Lab, which I'm advocating. And when you save them, they're .py files, which are inherently much more friendly to Git and GitHub It makes cleaner repos when you make changes in commit, because you don't have all that IPython notebook, which is the engine underneath Jupyter, JavaScript, or it's actually JavaScript to object notation pollution, JSON metadata is copiously generated and changed a lot as you use a notebook in either Jupyter Notebook Classic or Jupyter Labs. So why would you ever do that? The reason is because it's got built-in documentation. A few things. You get the ability to embed Markdown right in with a notebook. You can use it as a notebook, so it's a wonderful way to process or to document processes, especially long processes with a step-by-step order in which you do things. First do this, then do that. So it's in a notebook, alternating between code blocks and Markdown in order to explain what your code is doing, or to put it in perspective, to put a little story around it, maybe embed a little bit of graphics with standard HTML image tags. You put the graphics in the same directory and you can pull them up for display with the image tag. You can show SVG files that way. So you can do some really good documentation inside a notebook, as the name would imply. You can also have the output, and then the increasingly interactive output, I might add, but on first pass, the output of charts and graphs with a built-in matplotlib and with the easily added on Seaborn for different kinds of visualizations, and Bokeh and Plotly and Dash, and all kinds of things that let you do fancy visualizations, which are really JavaScript driven. All these things have JavaScript in them as their real visualization component, doing stupid web tricks in the browser. However, you don't have to deal with the JavaScript. You're just manipulating Python just like any other Python, and when you invoke some method of a Python library, it generates a graph as output that displays right in your Jupyter notebook. And that's a powerful way to work, because those things can be moved around and embedded into different things. They can be put into email attachments, they can be hosted on a web server, it can be turned into a web app. And so you keep this real shell game going as to, whether things are being run in a loosey-goosey ad hoc Jupyter Lab fashion or in a scheduled and automated, more server-based fashion. All right, so a fair amount of my previous videos have been about whether or not you move ahead on all this stuff for personal growth, spiritual, intellectual, emotional growth comes from learning Python. Of course, the answer is yes, because it leads to spiritual, emotional, and intellectual growth. There's no doubt about it. It's just like becoming multilingual, but other spoken languages with which I have had a great deal of difficulty. And, let me tell you, I've had a great deal of difficulty with programming languages too. I guess this is where I shift from talking about what's going on with my tooling from these highly abstract, highly web-oriented, highly graphical user interface, by extension of web, oriented projects in my life. Jupyter Lab and Jupyter Notebook type things and web type things are because the tools are so cool, and when you layer in NBDev, whoa, someone was coming up fast on the right hand side, but I'll lean over. So when you layer in NBDev, Jupyter notebooks lose their lack of appropriateness for dev work. They become more appropriate for dev work because particular cells from your notebook get auto-extracted into a .py file, which is in a parallel directory structure, nested one level deep, in the proper layout and format. Now here's the thing, here's what makes this so fundamental. People would say, well then why not just use the .py file? The answer is documentation and tests, automatically running tests and automatically generating documentation. The standard type of documentation that should be built into all your work by use of doc strings, a particular format, a convention that you use inside of functions with a triple quote syntax in Python, so that automatic documentation of your functions can be just generated by running a program against your .py file. So some people would say you lose doc strings when you use a notebook. Untrue when using NBDev. Not only will NBDev allow you to create those doc strings because the .py files get extracted, if you will, from the notebooks, but they also create a whole README file side by side with that by automatically generating an index.ipynb file that gets converted to an index.html file. So what NBDev is it's just a tool that does a series of conversions and transformations out of your notebook files by convention, that stages things for a PyPy package release. It puts it in the file arrangement required to turn it into a PyPy package. That root level directory of your Git repo, which generally becomes, but not always, a GitHub repo, but at that root level of your Git repo, like you've got a directory by a certain name, you've run git init inside of that turns it into a Git repo. That location at that top level of that directory is appropriate for things like Jupyter Notebooks, .ipynb files. They are not inappropriate. It's part of documentation. It's also good to put .md files there for Markdown. There's another file format, rich data formatting, it might be RDF or something, that Python supports. I'm probably getting the three letters wrong, but it was Markdown before Markdown. So Markdown only became popular because a particular developer who was very popular, Fireball or something. Well, he promoted it. It got picked up in the whole Hacker News, Yahoo, Y Combinator, Yahoo, incubator, Pulgram, that whole publishing technology angel startup collection of sites, of which Hacker News is its premium news feed, I suppose. Made popular Markdown, which is a way of creating documentation with simple, beautiful ASCII text. So you could create documentation that looks good directly in your text editor without having to generate it to HTML to understand how it's going to look ultimately output with prettier formatting using CSS tricks or transformations to HTML or what have you. Point is, you don't have to commit to a presentation technology when you're creating your lightweight Markdown, which is your documentation. So documenting things becomes easier. That kind of Markdown documentation plus notebooks that is further documentation with embedded sample code are the types of things that are quite popular to put and appropriate at the top level of your Git repo. One level deeper, in a directory by the same name as the repo, so it's usually something like, let's say, SEO Kata. So it's SEO Kata /SEO Kata, a nested directory of the same name, is where your .py files are put. Those are then called a package by convention. Sometimes there's _init, _.py files there to support it. Things that are run automatically for everything that's imported from that directory, so that you can have templating systems on imports done pretty easily. A very common thing would be to use that as an alias, because when you import that directory name, it's going to automatically grab for that dunder init py. That's what they're called, dunder files, for _. So this is a dunder init. Dunder inits initialize package directories, and then you could have that dunder init in turn import a package name .py. That's how you avoid shoving everything into dunder init. Dunder init is a shim for other .py files that are sitting there that get imported in turn. So nested imports are not foreign or disapproved of in Python. They're actually decent practice. The import system, and by the way, the actual internals here, how this is working, is radically cool and mind-bending, and has a lot to say about modern, still dynamic systems versus compiled static systems that run faster and have higher degrees of predictability, but can't do all the same stupid dynamic interpreted language tricks that a language like Python can still do, even though it's not strictly still an interpreted language. Everything uses some form of just-in-time compiled. The implementation may vary, and whether you call it a pseudocode system or an assembly compiler, ASM, the common assembly, nearly a binary for your hardware platform. You could even take that next step to turn the ASM file into machine code for your actual machine, so it's like a .exe. All languages have that in some form or another. Whether this is a virtual machine or a just-in-time compiler may vary, and different platforms certainly have favorite ways of referring to it, like JVM for Java. They like their virtual machine nomenclature. LLVM, built into the GNU C compiler, the GCC compiler, is another implementation of virtual machines. And this virtual machine stuff at the operating system level, or certainly at the API level, dates back to the dawn of Unix. It's what caused the digital revolution, because before that, everything was compiled for particular hardware. Therefore, portability of software between different hardware platforms did not exist. It was barely doable, because you had to rewrite low-level implementations in languages that are highly hardware aware, like assembler. Progress was made, and things were written in higher and higher level languages. BCPL being one of the earlier ones, which made the portability accomplishable by saying the platform itself, the operating system, is portable. And so long as you port the operating system, the APIs of the operating system go with it, and thus you can compile your code for that system. So that was, what back in the day the BCPL language was made for. BCPL was the language that allowed the earliest things of what we know today as the LLVM. They're lightweight virtual machines that are built in so that just-in-time compiling can target that lightweight virtual machine instead of your, much more detailed, optimizable against, I might say, true hardware, silicon underneath. So it's turtles all the way down, right? we can't function efficiently without abstracted virtual layers for simplification, for making simpler and simpler and less complex APIs, application user interfaces, until we get to interfaces as simple as Python. And as you peel away the implementations and go down in the stack, things get more complicated. Python itself is implemented in C++, and so you can look at the Python interpreter implementation in C, and most specifically where the eval function is written, because the eval function, the thing which static compiler people are allergic to, with a dogma, a religion, and a vigor that's really quite a sight to see, just suggest using the eval function to someone who came up through the traditional compiled C or Java computer science route, and they'll tear you a new butthole. However, such favorites as the named tuple in Python make extensive use of it for shortcuts so that neat things are possible. And the interpreter itself is using it, so if the interpreter is using it, why not other things you write that the interpreter will in turn use? Why keep these meta power tricks private to the interpreter? Let other packages you can write use them too. So eval is okay. I'll remember his name. One of the core developers, who's just a real pleasure to listen to and to see do live demos in Emacs, is one of the big advocates of this methodology. He wrote the name tuple. His name will come to me. But he's one of those true wizards who chooses Emacs as his eternal editor, because editors should not be tied to a vendor. Editors should not be able to be taken away from you. You should be able to create customizations and muscle memory and macros and lifetime habits around your editors, and that goes with you forever. And so there's really two ways to do this, through Emacs or VI. Normally I say Vim at that point, but honestly, there's so many implementations of VI. It doesn't have to be the most popular and people would argue bloated one, Vim. However, Vim is pre-installed a lot of places. Vim does have a particularly robust macro and vimrc, a way to configure your program to your customizations, ecosystem, a plugin ecosystem, good licensing, the developer's still alive and supporting it, thank goodness. What will happen when Bram Molenaar goes away? Well, honestly, similar things as to what happened with Python when Guido van Rossum stepped down from Python Foundation as its benevolent dictator. It went on. Vim will go on. It's too big to die. Not as big as Python, but the Vim text editor will go on. It will be improved. Here's my prediction. Machine learning will step in and clean up all those things people still don't like about Python or Vim 8.2 or whatever it's up to. But Vim has been out since 1991 and it's version 8.2. You gotta love that kind of stuff. Python's out since similar dates and it's up to version 3.11. You gotta love that. What that represents is an unchanging API. The things that you can hang your hat on day to day change at a very slow pace, so slow learners like me can keep pace over the years. Unlike the VS Code world, I say VS Code, there's a Freudian slip. You need VS Code to use it. You need VS Code to make JavaScript usable. So Microsoft stepped in and filled in a void and said, everyone has to manage JavaScript now in these complex ways that Node.js makes required. Nested directories within directories and parallel directories. And So file directories had to be built into text editors in order to make JavaScript usable, and searches across those nested directories. Oh boy, it's quite an awakening having to take over a Node app, but I didn't really have to. I passed it on in turn. I passed the baton on again. But it's not pleasant, and there are plugins for Vim, but I figure once you got to do these plugins for Vim, the Nerd Factory, there's a bunch of them out there that take care of this file tree fuzzy matching. As you type in file name searching, file names are searching the contents of the files. I've seen some really profoundly cool fuzzy matching Vim Kung Fu with directory trees. Not interested. Nerd Tree, I think this might be its name. Not interested. Give me a 100-line vimrc configuration file for Vim with maybe a few macros thrown in that I can throw into a GitHub repo and take to me to any machine I sit down on, and I'm happy. Give to me yet another ziggurat of plugins, albeit for Vim, just to make it usable, and that's a fragile dependency. I don't like that. I don't like plugins in Vim any better than I like plugins in VS Code to make VS Code, which makes JavaScript usable, and SSH plugins to make VS Code usable. A ziggurat of strange dependencies, very tied to vendors, very tied to platforms du jour. Yes, it's an Electron app, and yes, it'll run on the desktop of anything, but will it run on your phone? Can you get an Electron app in mobile? I can get a terminal in mobile. I recently logged into a terminal from canoeing down the Delaware River on my anniversary. It might have been a year ago. But I had to do something for my boss, and I was on the Delaware River, and I got the text message, and I SSH'd in using VPN to a terminal from my iPhone in a canoe on the Delaware River, ran a couple of scripts, and logged out. So Microsoft's trying to make it so that GitHub Spaces gives you approximately that same experience. You can get into an instance of VS Code through the web, so inevitably through a browser, if not today, then certainly soon, and have VS Code coming up through it, embedded into a web page in your browser via your GitHub login. Pretty magical stuff. Magic wands. The web has a lot of magic wands and a lot of hand waving and a lot of really cool power tools. Look, it's working. Make your bosses happy in the short term. But you have a ziggurat of dependencies, and what I mean when I say ziggurat is, pyramids of layers where it's, a big base and smaller going up. That's a ziggurat. Central and South American pyramid. A lot of them are ziggurat shaped. So when I say a ziggurat of dependencies, first you got to install this, then you got to install this, and then you got to install this. And no matter how much it might be made transparent to you with wrappers and such, it's still a lot of moving parts down there. I was pretty allergic to the Selenium web browser testing automation platform for many years because Selenium required the Java runtime engine, which, required other stuff and so on down the line, and it just made what could be like 100 megabyte server. The servers can be 100 megabytes large in their entire software footprint. They were called webheads. They didn't have to display a graphical user interface aside from the web site they were hosting. But on the back end, there was no desktop that you could log in, not Windows, Mac, or even Ubuntu or otherwise. It was just a headless web server, webhead. So even though I didn't do a lot of web development, I would use small footprint webhead-like servers for all my scheduled work. It's like you need something run in a batch script style thing. Forget Celery, forget all these pipeline scheduling deployment systems. Just give me generic Linux. I'll CD into the correct directory. Somewhere under etc, there's a systemd directory. Under the systemd directory, there's a system directory. Somewhere nested in there is a place that with, root access to your system with super user, so you sudo vim filename.service, and you're writing yourself a Linux service that you can stop and start with conventional commands, so you don't have to write all these bash scripts. That was the old-fashioned world. Init.d is what I'm describing. You'll still find this on the Gentoo, GIF, what have you, distro of Linux. You'll still find it on the Arch distro of Linux, whose repo system is called Pacman, by the way. So there's the Debian package manager that people know as apt-get. There's the Red Hat packaging management system, RPM, that people know as Yum a lot of times. And then there's the Arch Linux Pacman repo system. So they each have them. Tiny Core Linux has TCE load, TCE. So they all use these same tricks. So there's some lack of portability of scripts between Linux, especially if you're automating against the repo system. Then choose Debian. Can't go wrong. Microsoft chose Debian. Or choose RPM. It doesn't matter. You can port these scripts between repos. It's understanding and porting at that level is so much easier than in deep API implementations. That's like the whole point of Unix/Linux. It's the portability. It's universal portability, universally portable operating systems. And it delivers on its promise. So this video is becoming about other things. I started talking about tooling, modern tooling, and how parts are in motion. It ties to this. I use the now standalone version of Jupyter Labs in order to create files, PY files, that I move into the Linux systemd directory so that I get automatic scheduling without Celery and other, scheduling management systems. There's so much choice in technology. And name your stack. Under the Node ecosystem, there's so much choice. Under the Python ecosystem, there's so much choice. Under the Java ecosystem, there's so much choice. So you make your choice of runtime environments. Your runtime environment choice, which would be, Java versus Python versus JavaScript. And within that, you make your package and framework choices. Frameworks often have embedded runtimes. So, and then with that framework or package choice, you then have a plugin system choice. And you can build so many similar things out of so many different foundational package choices. It seems volatile. It seems short shelf life. It seems fragile and brittle, and setting yourself up for failure, because how could you possibly ever make the correct series of nested choices? The answer is choosing your abstraction levels with a great deal of deliberateness, a great deal of understanding, and having gotten to know yourself. So quite honestly, there's a giant split in people out there. Those who will ever become familiar and comfortable with the command line interface, the Unix like terminal, the Unix terminal, the bash shell, the script shell. The terminology goes on and on, but every variation of this is talking about the old school way that Linux was, the old school way that Unix was interacted with before drag and drop graphics, mouse, pointers, touch screens, and, pixel addressable resolution. You couldn't address pixels. They had intermediary things that generated characters. That's why they were text terminals, and that was even a big advance over line terminals, which was a big advance over just printers as output, like the old Batman movie interfaces to computers. So we take a lot for granted today, and in the whole process of going from typewriter type interface with computers to graphics, 3D games, simulating reality that we have today, there have been inspired steps along that way. There have been inspired steps along that way, which are not modern virtual reality with all its dependencies and processing overhead, and which are likewise not the very earliest interfaces to computers. The command line interface, the naked command line interface without a shell. So shells add to the bare bones features command line interface things like histories, where you can use the up and down arrow to get back commands you recently typed. That's not built in to the Unix shell interface. The naked Unix shell, naked, it's not a shell, because it's not using a shell. A shell or a shim, these are all things that superimpose features. So before there is a shell or a shim, it's just the command line interface, the CLI. The CLI can run a program by which everything that happens looks just like the CLI did before, but now you're running through a shell. In the early days, there was the ASH shell. I forget what it stood for, but Berkeley, that released early versions of Unix, because Ken Thompson would visit Unix with early versions carried with him from Bell Labs, created their own version, the Berkeley ASH shell, or the BASH shell. That became the most popular shell to add things like command line history to the Unix CLI. So people stopped using the term CLI very much and started using the version shell or bash shell. And even to this day, when the now uber popular Ubuntu, or Ubuntu, whatever you care, tomato, when you bring up its terminal, command key T or whatever, starting to type terminal from the search or however you do it, what it's going to bring up is the modern version of a bash shell. Canonical, the company who makes Ubuntu, chose the bash shell to base their thing on because it was the most popular. Microsoft chose Ubuntu, Canonical, as their Windows subsystem for Linux default version partner. So Microsoft, by extension, chose the bash shell. So these things that have these long traditions going back to 1970s are still as alive and vibrant today as they were back then. This reads to me as a timeless and universal and fundamental plumbing of the internet API. The timeless, obsolescence-resistant API is here. And it's mostly called the Unix bash shell. Nobody wants to use naked Unix scripts anymore. People want to at least have, at minimum, the bash shell level of script augmentation for command line recall with the up and down arrow keys at very least. In command line completion, you start to type something, you hit the tab key. If a file of that directory, of the file of that name is in the directory you're CD'd into, it'll auto-complete it. If there's multiple files that have that same root component of text, it'll auto-complete it to as far as it can, and the next hit on the tab key will pop up a sort of menu of the different files, and you can up and down key to the selection and hit it, so you can completely avoid typing all but the first few characters of a long, complicated file name. So people like that. When I say the timeless platform of tech is Linux, Python, Vim, and Git, it's this part of Linux I'm talking about. It's taking advantage of Bash shell features, including the writing of .sh files, the writing of Bash shells, which you execute by typing sh space filename.sh. That is a way that you can wrap any file inside the way a Linux or Unix Bash script is run. And this is how ultimately you can put the parameterized invocation of Python.py files in the systemd directory of pretty much any modern Linux, except for Arch and Gentoo, for which you would use the initd. And we're old school, more power to you, right? If you're still writing Bash scripts to start and stop services, to restart them, that's badass. Initd will never die. Systemd is getting the power of initd at merely the cost of one more monolithic system, hacking surface, layered on to a system you're running. Done because Linux needed to be able to do this and was jealous of Apple's version of Unix already being able to do this. I couldn't tell you its name, but it was developed for Darwin, Apple's version of Unix that they, contributed back to the free and open source community. They're not keeping it closely held, but it's mostly because they had to. If they wanted to derive, their own Unix kernel that they could freely use, they had to give back a certain amount of the custom work because of the details of the GNU 2 General Public License, GPL, the same way TiVo, it's not TiVo, TiVo caused GPL3 to be created, but the same way Linksys, now Cisco, had to give back the WRT router code that they did, making the WRT router one of the world's most hackable little wonderful pieces of hardware for the world to ever see. We probably won't see stuff like that again. If you wanted to create a traffic sniffing router components that you can see what kind of communication the built-in Minix operating system in your Sandy Bridge Intel-based or newer processor is doing, you could put that machine onto your network through a WRT router who is made special to listen to calling to mama controls coming from your secret operating system on your machine. And you can do that. You have those capabilities when Linux, Python, Vim, and Git are your basic developer stack framework. I don't even know what to call it, right? It's a pseudo platform. It's a platform that exists within any other platform optionally, with elegance. More so on Windows these days because of the Windows subsystem for Linux. So you get your L component, your Linux component, on the Windows platform with WSL2, Windows Subsystem for Linux version 2, which is a little tricky to install on Windows 10. I'm going to do that switch, that move over to WSL2 on Windows 11. So you'll see me do my Windows 10 to a Windows 11 upgrade, because only on Windows 11 will the Windows subsystem for Linux give you graphics, native graphics integration. It's a strong incentive to get off of Windows 10 and onto Windows 11. It's even compelling me along. And so there's really clean integration now between Windows and Linux. Linux as a subsystem. So if Linux is a subsystem of Windows, and you start to learn all the generic tools of scalable production, favorably licensed components that won't break the bank when you scale. That's why Microsoft was forced to make the Windows subsystem for Linux. No one in their right mind is deploying scalable apps on Microsoft operating systems, because it'll break you on the licensing. You'll break the bank on the licensing arrangements. Microsoft knows this and has to lean into it. So now they're a free and open source supporting and promoting and sponsoring company. They embedded Linux and they hired the creator of Python, right? So it's not just a Linux story. It's not just a Windows subsystem for Linux story. One of the most common things you will do on the Windows subsystem for Linux is run filename.py. It will be to run Python space filename.py. Linux Python. That's where you get the Linux and Python out of me advocating the LPvg platform. Capital L, capital P, lowercase v, lowercase g. LPvg. Okay, I gotta get it smooth. LPvg. I get to create the pronunciation preference on the invention of a platform. What should it be? That'll probably be the most popular. If I put this at the beginning of this hour video, that would have probably been the single popular, making me blow up finally on YouTube thing, but it's at the end of the video, so only my diehards will hear it. Da-dump-dump. LPvg shall forever forward be officially pronounced LPvg. 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 It's a made-up word, see? LPvg. The platform is LPvg. Are you talking about LPvg? I'm talking about LPvg. It's all you need. It's all you really need. I'm not saying use only this. I'm not saying use just this and use it as your primary way to create scalable, in your back pocket, breezy, easily written apps that you could throw out there to schedule. But I'm saying it's in your back pocket as a one that you can develop muscle memory on, that can never be taken away from you by designed obsolescence, changing of user interfaces. Fundamental changes of platforms over time will do this to you as well. Merely just resolutions of desktop systems. You feel things getting weird in the 4K world as you bring a text editor up in there with fixed locations, having to go up there for this and down there for that, and text getting tiny because of DPI display issues that you have to compensate for. So why use such high resolution monitors in the first place? I'll even get into that. Yeah, there's no reason to be using 4K TVs for development work. What are you, nuts? Just use a sub $1,000 laptop, because stuff is going to go wrong and you'll want to get a new one. Even that sounds a little bit expensive. I've been trying to keep it at about $800. I like the Microsoft Surface laptops. I think it's Surface Laptop 4 they might be up to. I think that's what I'm on. But they're slick and they're svelte and they've got a beautiful screen and they work with styluses wonderfully. Microsoft pencils or styluses that don't need to be kept charged and have this great eraser bit. I can't say enough wonderful things about the build quality of the Surface, of the Microsoft Surface laptops. I've also been on just the Surface tablets using the kickstand. So eventually the screen cracked and I didn't get another Surface tablet. I was on I think the 2. And I know the new one based on the ARM processor, 64-bit ARM, was quite a revolutionary product, and they put an X in that name, I'm not sure, but taking a page from Apple, switching processor models. But I like a rigid keyboard. Even if it's low profile, it's got to be rigid. I'm a keyboard dandy. And there's a certain feel that Apple, I think, got to first with the low profile, highly tactile keyboards. They went away from it with these awful chiclet membrane things and then backed up off of that again to, again, a nice feel. But that nice feel, low profile keyboard that finally got me off of IBM Model M buckling spring keyboards, because boy was I a real keyboard dandy. I must have driven people around me crazy, some of the places I worked. Because in a cubicle working environment, that is not very friendly to your cubicle neighbors. But for a while, because of the open office cubicle environment, I needed to do that to get into the zone. So it was either, F me or F them. And I chose F them. Whatever that makes me, I don't know. But it took me a long time to be able to get into the zone or the flow in a equivalent, equally quality way, but it happened on a certain low-profile keyboard that Apple had developed for their MacBook Airs, and Microsoft has fully and adequately knocked off that, like they do everything else from Apple. And so that's acceptable on this laptop I'm using, which I try and keep to under an $800 spend, around an $800 spend. Why pay more? So the missing piece there is virtual desktops. People hardly use this feature. I see them all tabbing around this god-awful, postage stamp collection of applications they have running, when they could just be swiping left and right between full screen apps in a preferred order, so that they know that their most frequently used app is all the way to the left, so just go left. Their second most frequently used app is the second screen, so go right once. You can go to left all the way and go right once to get there. There's absolute location. It's relative, but, absolute movements, because, go to the left all the way and go to the right once. Is that relative or is that absolute? So it's timeless is what it is, because a ribbon of virtual screens or virtual desktops, whatever you want to call them, is achievable on both uber popular mainstream desktop platforms. Of course, Windows and Mac OS both let you do this, horizontally oriented virtual desktops to swipe between. And Ubuntu lets you do it too. It lets you do it, which is GNOME, the now popular GNOME desktop, because Ubuntu got rid of their own Unity, which worked the same way, by the way, with the X by Y. They let you do a matrix of virtual desktops, so you can swipe up and down and left and right, but that just was too much for my mind. It blew my mind. So a horizontally oriented ribbon of virtual desktops, usually about 7 seems to be the magic number for me, swiping left and right, lets me have the first 3, usually, definitely the first 2, but now more and more often with standalone Jupyter Lab, the first 3 as wholly dedicated apps that are hardwired parts of my everyday work. The first, of course, being a Linux terminal, already with the Vim text editor, with my journal loaded from a particular Git and GitHub repository. So journal I think it's .txt, because I avoid markdown auto formatting in Vim. Who needs it for a single text file for life file? You don't want formatting happening in something that's going to grow to be millions of lines, right? So my journal.txt is, a few 100,000 lines. I might be up to 500,000 lines of journal, just personal journal. A few years back, I decided one text file for life. If I started writing now and kept going like Alexander Hamilton for my whole life, I would not be able to even begin to tap Vim's ability to keep, large text files open. It's optimized for that. The people who accuse Vim of bloat, anything can be accused of bloat. There's reasonable amounts of bloat. There's a standard library, core component bloat, which is allowable up to a certain point. And Vim pretty much fits in that category. It's not as gentle on your memory as NeoVim and things like it, but I'd certainly rather be in NeoVim than brain-dead text editors like Pico and Nano, which are always there, but you deny yourself the satisfaction of nearly telepathic control over text that improves over life. You might be in PyCharm for a few years, but PyCharm is just like TextEdit, which is just like Sublime, which is just like Notepad++, which is just like PFE, which is just like every text editor before it, which for thousands of tiny little nuanced reasons will not be there forever, will not be supported forever, will let you down in various ways over the years, will not let you edit files directly on, headless systems. If you gain the ability to log into computers through that command line interface, the Unix or Linux-like shell, those other text editors are not preparing you for that world. You will now be dependent on VS Code running extensions to let you SSH into remote servers, and you'll say, thank goodness for Microsoft and thank goodness for Power Tools, but I'll be saying, you're just dependency-laden on heavyweight software stacks that have gone away a lot in the past, causing disruption. People who've only been in the business 10 or 15 years have survived one cycle and downplayed it in their mind, or are these profoundly talented multilingual type people who just pick up every environment super fast and are proficient for it, or they're posers. They're finding some other way to make money off of it than to be in the zone, at one with your tools type master craftsperson. So I clearly favor my skills forever improving. Learning one text macro system for life would be a great example. How you record and play back macros is a quintessential example of the muscle memory dependency and benefit and power that can be brought into your life with a text editor, and how terribly disruptive it can be when you change text editors and your macro system changes. So I'm pulling right out in front of me. Yeah. So driving is one of these things that taps very different places in your brain than talking. Humans do multitask naturally. Humans can't multitask. You will find both opinions expressed. Both are correct, and it all depends on the details. Nuance is important. Anyone who tells you nuance and just shrugs things off as non-important as nuance is trying to trick you. It's that there's nuance, and let me tell you how important that nuance is. Here's what you have to get right and why. Here's the principles, the first principles that are different in this software execution environment or stack that is completely different in this other software environment or stack. That Python versus Node.js JavaScript is full of that kind of nuance, right? It's not nuance, it is fundamental concepts. And it's really interesting seeing ECMA script evolve to be more Python-like and getting rid of the necessity of curly brackets, of allowing variable scope to escape anonymous functions when you use the arrow version of anonymous function. It's so convoluted and weird seeing ECMA script evolve that whenever I investigate going, oh, isn't it getting as good on the JavaScript side as it was born on the Python side? And I find anonymous arrow functions to change the way variable scopes work, I get a little pang of anxiety, and that's how it's done. And then I get a little sigh of relief that washes over me going, thank goodness I don't have to be coding that way. Sure, Python's scope is a little bit weird and a little bit different than a lot of other languages, but once you get it, and once it becomes intuitive because you start doing things that get that benefit, it makes tremendous sense, and you miss it when you don't have it, which is why JavaScript was coerced to add it. Different scope for variables. Where things can leak up to global intentionally. Sounds like bad practice, but less bad practice than you would think when everything is a package, when everything is an importable package. Global variable scope becomes properties of an object. So, purists will often throw wet blankets on anything a Python developer does, saying, oh, that's the way things were done in the 60s. And the truth is, they understand it even less than you do when you're doing things that might look a little bit like old school, like, global scope variables, knowing that when your package is imported, that thing is going to become an easily accessible property of the, package of that name. Package being itself optionally executed code when you import it. People generally don't do that. And that's where the if dunder underscore name equals dunder underscore main, where dunder name doesn't have quotes around it and dunder main does. One of the strangest conventions in Python. That's why that is there. If you want code to run when imported as a package, that's where you put it by convention. So if it's imported as a package, it won't run. I sound like I contradicted myself right there, but I guess what I meant to say, that's why when you run it from the Python executable, that code block will run. Python space filename.py will run things in that name equals main check. But when you import that package into another piece of code, which might be being run that same way with a Python executable, the contents of your imported package won't run because it won't, meet the criteria of name equal main. So maybe I'm just rambling now, but what I'm saying is that no environment is perfect. But from a pragmatic standpoint, Python is as close as it gets. Ruby, of Ruby on Rails popularity, is a very capable language, but it is overly inflicted by object-oriented purity, the way Smalltalk was. You don't want to be forced into that kind of interface for everyday work that lives better in, other, interface conventions. Imperative is what like HTML and SQL are. It's just like the spoken language implementation doesn't matter. Procedural, which is the writing of functions. You would think that's functional, but no. Functions that have no side effects, that have nothing that is not through the formal API, passed in and out. That's called functional. That would be F# and Haskell, and a few other things whose goal is to keep bugs from ever getting into software. Procedural programming can have side effects. Again, I feel like I'm rambling a bit. But all these things come together to say, look, if what you really want is the ideal replacement to old-fashioned Unix script or Bash scripts, because no one's really going to live in Bash scripts. We need some conventions to ease the pain of what Unix/Linux inherently wants to try and get you to do, which is to run other scripts in turn. So Unix/Linux is all about scripts running scripts running scripts, and a cascading orchestra of scripts being run, oftentimes with parameters, so the scripts are not run the exact same way every time, and oftentimes with non-blocking I/O, so that scripts can be run that don't have to finish before the script that calls it can continue. So that's Unix and Linux, and that's the spirit of the thing. And happily, one of the types of scripts that can be run is .py files, which in turn can be parameterized. So your .py files can do different things with different time ranges, using the current date, using different property names against Google Analytics and Search Console. So by learning a little Linux, little Unix, you can hand control over to Python and be in a very much preferable API land, right? Because all these things are APIs. Unix Bash script is a programming language with an API, an old school complex one with too many backticks and slashes for a lot of people's taste. So things replaced it over the years. Bash replaced Unix script, shell script, and then Perl scripts, in great part, replaced Bash scripts. And then Python scripts replaced Perl scripts, and that's where we are today. Python scripts are still replacing Perl scripts. Perl was something we had to do to get to Python. But the language of the cunning linguists that has as many obscured, kludged together ways of doing things, so that obfuscation contests have become a big thing in the Perl language. Python has just one way to do it. Come on, be serious, really? So, Python now has more than one way to do things because of f-strings and list comprehensions, but over time things can settle down to the one best, truly most Pythonic way to do it, and generally that should be taught to you by Kenneth Wrights of the requests package, because he first grokked APIs for humans. Kenneth Wrights is one of the first people who said, hey, look, yes, even Python is capable of complex APIs to support all edge cases, and that's what the URL lib in Python had to do, because Guido van Rossum makes the, benevolent dictator decisions that the API will be object-oriented in nature, and also quite difficult because there's a lot of edge cases in HTTP stuff, and we got to support it all. Whereas Ruby says, oh, just make an HTTP call. And just use regex right in that same line. I won't stop you. So Ruby embedded the most common use cases directly into the Ruby language, making one-liners in Ruby quite beautiful for HTTP and regular expressions without package imports even being required. Whereas Python forces you to do imports and to even go to third-party libraries for humanly usable APIs that repackages URL lib under the requests library. And if you want concurrency, it's HTTPX, which is API compatible with what? The standard library? No, with requests. So competitive third-party packages for HTTP are going for API compatible with other third-party packages, which have just become that popular, and that's Python. compromise like Unix/Linux itself is built into the language. There will be no one best pure way to do a thing, but there will be one best 80-20 rule compromise way of doing a thing. And that turned out to not be Bash script. It turned out to not be Perl.pl files, which were all the rage on the web in the early days. That was the most original P in the LAMP stack: Linux, Apache, MySQL, and Perl. CGI bin directories. That was the Perl land. But it was unacceptable. It didn't grow well. It didn't age well. So the other honorary P language is not honorary. Ruby's an honorary P language, but the other P language that isn't PHP, Python, became the heir apparent as the sysadmin, DevOps, DB admin, hacker, I might add, the Metasploiter language of choice. Pick up a copy of Alt 2600. Look how they're telling you how to hack systems. It's a Python world like it used to be a Perl and Bash script world. It's the P in the pool of tech. And happily, the P in the pool of tech now is a wonderful, robust, obsolescence-resistant, love-worthy language. So you use Linux to run Python, Linux Python. Vim and Git, I'm getting close to my destination. I could go on forever with this video. I'm an hour and 20 minutes into it. But, suffice to say is, a lot of my content to come will be to deal with the fact that VS Code is both exactly as wonderful a product as it's billed to be, and is the end of your career because you're now a Microsoft person. There were so many ways of just becoming. Think how much you were a Microsoft person by starting out with Word and Excel first, right? You never lose those Word and Excel habits. It sets the expectation. So Google had to copy. Well, it was Rightly originally, and some other companies that were acquired and collectively turned into Google Docs. I knew some of those Rightly people from New York City before they were gobbled up by the Google machine. But Rightly became docs.google.com. Something else became sheets.google.com. But all those apps copy the Microsoft apps, which in turn copied things before them. Microsoft is an original on those fronts. They put Lotus out of business, or Lotus had to be bought by IBM, and before that it was cross-platform. VisiCalc on the Apple II was probably the one that started the whole Excel lineage of software type. Spreadsheets, ledgers, computer-based ledgers. Excel owes a lot to VisiCalc. And so each of those has a story going back to WordPress, or not WordPress, that's modern web stuff, but WordStar, WordPerfect. WordPerfect and WordStar is where the docs.google.com and Microsoft Word lineage go back to. But it all, shows you how much predisposing is done on the first software you learn on and you're exposed to. That's why Apple tries to get their computers into education, or certainly did back in the day. Get your computers in on education, students learn on that, and they're predisposed for the rest of their lives. You see that in computer science, what computer science departments teach for Comp Sci 101 all over the world. It was for many years Scheme, the Scheme derivative of Common Lisp, because it's so friggin' powerful and so friggin' fundamental, and teaches you so much of the meta stuff and machine learning stuff that can be done with computers. A wonderful art that has been lost with the death of the Lisp platform. Lisp was its own optimized hardware platform back in the day, used for computer graphics workstations, right? Before Intel-based PCs took everything over. There were MIPS machines and SPARC workstations, and a lot of that used Lisp hardware. It was as Lispy as today's computers are Unixy and compiled C. It was a bizarro alternative world. So, where was I going with that? Yeah, comp sci departments liked to teach that stuff. Scheme on Lisp. The scheme dialect of Common Lisp on whatever modern hardware. It didn't have to be a Lisp hardware. You could run Lisp on Intel hardware, of course. x86 hardware. But it was a huge violation of the 80-20 rule. It was truly wizardly stuff. It's what aligns with Emacs. A lot of Lisp users use Emacs as their editor, and they would be running on the incompatible time-sharing system if they could be, going back to the days of the Media Lab, the MIT Media Lab, where a lot of the original innovation in tech happened, in infotech happened. And I'm getting text messages. I'm going to have to wrap this up soon before a call comes in. So I'm going to say thanks for joining me. Hope to see you again soon. And don't forget to subscribe just in case that call comes in. I forgot to go into Do Not Disturb mode, so this video could be interrupted on my iPhone. Let's just quickly wrap this up here by saying comp sci departments switched to Java, to C, which was too hard, Java, which was less hard C. That's why the Java bias swept across the world. The whole globe gets wrapped up in these, what's in style in comp sci departments. And then most recently, it's been switching to Python because while not as pure from a comp sci standpoint as Java or C or Scheme that came before it, it's pure enough. Python does teach the comp sci concepts, so long as it has the proper qualifications that go along with it. Here's what's quirky in the standard Python implementation. There's some quirkiness, but it lets everyone be productive delightfully fast, and that's the appeal of Python. And then it grows with you as you grow. You plug components in and see if you want. You are not limited to Python. You're partaking in a whole, what used to be considered ungodly alliance of the sysadmins and the C developers could all agree on Python. So, in more modern days, Unix-based Macs were an unholy alliance of the design crowd, the Quark Express using graphic design crowd, and the Unix geeks, the comp sci geeks. So this aligning of unlikely camps and unlikely bed partners is one of these common themes that goes back. And so the latest unholy alliance, which is a bandwagon that you should jump onto for all the wonderful benefits it brings, is Microsoft and Ubuntu via Canonical, via Windows Subsystem for Linux. Get your butt on Ubuntu, terminal shells, Unix shells, on your Windows system. You're setting yourself up for the future. You'll be doing yourself a big favor. If that's too intimidating, download and kick the tires on my free version of Linux called Levinix, which lets you get into a terminal shell. If you're skilled, there's some interesting gotchas there. Without even doing an install. It's like a 20 meg download, which is nothing these days. Once you inflate it, once you uncompress the zip file, it's about 60 megabytes. And after you run it, it might get a slightly larger footprint, but it becomes, a Linux desktop on your desktop running in a little black window using QEMU, Tiny Core Linux, a few other interesting things that I spun together, so that you can basically do the Dune litany against fear. mutiny against fear. Purge out the fear of Linux terminal, and then run some Python via that Linux terminal. And that sets a stage for copying and pasting things from Jupyter notebooks, Jupyter Labs, into automated systems, and bridging the gap between these seemingly unbridgeable two worlds. And then using NBDev to do that formally and cleanly and beautifully, so that you can beef up the testing, the automatic tests that are run on your software for continuous integration and CI, continuous integration and deployment. That's a benefit of NBDev, as is built-in documentation of various sorts. So people will say notebooks detract from these types of things, from it having a really good life as a Git repository and a GitHub repository and other little things like that, but it doesn't. Notebooks are the perfect environment for doing that sort of dev work, and then sort of booting little select pieces of it over the fence into the 24/7 automated world, which can be just generic Linux, doesn't even need a task processing queue to run. You can just use systemd. So that's where I'll finish here. Some beautiful concepts there that really stage things for the next steps on these videos that I want to make, which I'll be bringing you through doing all this for real, magic fairy dust, so that you can become a highly abstracted, low-level developer through the Unix-like terminal. Thanks for joining me. Hope to see you again soon, and don't forget to subscribe.